Okay, so you have to find the cube roots of the complex number 1 plus I. So if you look to the right, I drew a complex plane to show you what that number looks like. So 1 plus I. 1 stands for the horizontal component. So we go 1 to the right, and then I represents the vertical component. So we go 1 vertically after going 1 horizontally to the right. So it takes us to point A. And as you can see, it's going to lead us to an angle that lives in quadrant 1. So that's now we'd have to convert this complex number here into polar notation. That's why we find the magnitude and the angle. So to find the magnitude, you do the square root of 1, because that's the horizontal component, plus 1 squared, because the 1 instead of I, because we do the coefficient of I. So what's the coefficient of I? 1. So you do square root of 1 squared plus 1 squared, you get square root of 2. So that's the magnitude. And then to find the angle, you will do the inverse tangent of 1 being the opposite side to the angle, over the adjacent side. So that gives you inverse tangent of 1. And if you know your unit circle and you know from the drawing that we need to be in quadrant 1, it's going to be 45 degrees. So just like that, you turned this complex number 1 plus I into square root of 2, magnitude, and angle 45. Now you're ready to apply this formula. And it should have been covered. I'm pretty sure it's been covered in whatever class you're in. So what you do is you take the nth root, because here n is 3, you take the cubic root of the magnitude. So the cubic root of square root of 2. And depending, because you have 3 different options, 3 different solutions, k equals 0, k equals 1, k equals 2, 2 because it's 3 minus 1. So we have to run this formula through 3 iterations. So the first one, I'll do the first 2 and then leave you to do the last one. So z0 will be the cubic root of 1, the cubic root of 2 of square root of 2, meaning square root of 2 to the 1/3 times cosine of, so we do 45 plus 360, and then the 360 is multiplied by 0. So it's times 0 over 3. And then we do the same thing for I sine of 45 plus 360 times 0 over 3. If you clean that up, that will give you, so what is the square root of 2? That is really 2 to the 1/2. So 2 to the 1/2, 2 to 1/3. And then you have cosine of 45 plus 360 times 0, that's 45, over 3, that's 15. And then that's going to be the same angle for the sine. So sine of 15 degrees. And really, 2 to the 1/3 to the 2 to the 1/2 to the 1/3, you multiply the exponent, so you get 2 to the 1/6 multiplied by cosine of 15 degrees plus I sine 15 degrees. And this is really the first solution. This is z0, because 2 to the 1/6 is the same as the 6th root of 2. So z1, I'll just set up z1 and let you finish it and do z2 as well. So it's going to be 2 to the 1/6 times cosine of 45 plus 360 times 1, which is just 360. So, and then we still divide by 3, same angle for I sine. So 45 plus 360 over 3. So with that, you can do the rest of the work for Z1 and also Z2, and you will see that the answers match up what match up with the answers from your book. Thank you so much.